if you have a particular term or a particular equation, so you want to see if it is dimensionally correct, because every quantity that is inside that has particular unit. And then if they are quantities, they can either be what, fundamental, or they can either be derived. And if they are derived, so if they are derived, meaning that they are built on the combination of two or more of the fundamental quantities, right? So dimensional analysis need to understand how these derived quantities, mostly these derived quantities, relate to these fundamental quantities in the particular equation or in the particular term that you are having to analyze. Okay, so that's what dimensional analysis does. So we need to understand. In this journey, we want to understand how that is done. That's basically what we want to do. And ability to do that, right, will help you to ability to do that will help us to actually do a lot of things. So it's a very powerful tool that will allow you to find the unit of quantities and all that. And right now, let's try to see how these things are related. There are some of the things that you need to know, right? We talked about the fundamental quantities already, but then formally, what are dimensional analysis? Let's look at this. So dimensional analysis is just a method, right? It's a method that we use to show how quantities are related to their fundamental quantities, especially of time, mass, and length, right? So you just have a quantity and they give you like unit of like a quantity like energy, and a quantity like work, a quantity like velocity, a quantity like acceleration. How are they related to their fundamental quantities? We have seven fundamental quantities, remember, right? Yes. So how these derived quantities relate to that? So and then when all these equations in a particular equations, all these terms, a lot of terms are used. How are these how do these terms that are used in a particular equation agree fundamentally? So dimension analysis does try to address how to address to see the relationship, and actually make sure that a particular equation is valid. A particular equation can be used to find the unit of a particular symbol and all that. We'll get into that, but right now let's see how this thing is done. So fundamental quantity dimension analysis does it. It's a method. It's just a method that we use to show how quantities are related to their fundamental quantities, especially meaning most of the time, in most of the cases, we'll be using time, mass, and length mostly. Okay, so now here is a list of all the fundamental quantities that we have. We have the amount of substance, mass, length or separation, time, temperature, luminous intensity, and electric current. So when they say dimensional analysis, when we are talking about dimensional analysis, we are basically there are some of the things that you need to know to do that. So there's a particular symbol that we use around the term, the quantity. When you see this, we put this around a particular term, right? And we have the term here, or let's say the quantity here. Then what we are this square bracket, what is trying to do in this particular exercise is that this square bracket is telling you that we are trying to find the dimensional analysis of this particular quantity. So if I have amount of substance, right, we have to convert it to, if you put this in around it, meaning you have to convert it to this dimensional quantity. And dimensional quantity symbol for amount of substance is capital N. Now let's talk about mass, right? So for mass, if you do dimensional analysis of mass, if you convert something in mass, then you are going to have capital M. They are usually in capital M's and stuff. And then length or separation, they can be breadth or anything that's width and all that. Height, they are all separations, right? And we use capital L. And then for time, right? For time, we use capital T for time. Temperature, for temperature, we use the theta, but we will not use most of these guys at this level, right? So for luminous intensity, the dimensional component and the dimensional symbol of this is just the J, and then for the electric current, the dimensional component of it is capital I. Yes. So these are the dimensional symbol of these quantities. So whatever other quantities that we have, right, we'll be able to break them down into these components. But the most important one that we'll be using are these three. Mass, length, and time are the most important one that we'll try to familiarize ourselves with mostly. So yeah, our focus will be on these guys. They are the one that we focus on: mass, length, and time. We'll be able to break quantities into that. But then for the other fundamental quantities, these are their fundamental symbols. So when you have something in mass, so you can convert it to its dimension, into its dimension form. So if you want to see a square bracket be around a particular quantity, it is telling you that you want to do the conversion, you want to convert that into its dimensional analysis format. So square bracket around something mass is going to be capital M. Square bracket around something that is separation, right, or length or height, is going to be capital L. Square bracket around something that is time or period is going to be capital T. We'll be using all that, so we need to keep at least these three in mind. Note, however, that some of the equations, right, will be having numbers inside. So if you take the dimension analysis of a number, right, the answer is 1. So dimension of any number, it can be 10000, it can be 1 billion. The dimension analysis of this is going to be 1. Let's keep that. Dimension of analysis of numbers, dimensional analysis of numbers or constant is 1, or any constant. So some of the equation may have constant k, right, is 1. So that dimension analysis of constants are all 1. Dimension analysis of all numbers are all 1. These are things that you need to keep in mind because you'll be using them mostly when we are doing dimension analysis of terms. That's what we have to do in the next sessions. So we will advance.